In this video, I'll show you how to solve the ALEKS problem called calculating the wavelength of a spectral line from an energy diagram. The problem is going to give you an energy diagram that's going to resemble this. It might not look exactly like this. You might not have this 3 lines. You might have more or less. The first question is going to ask what the energy is of the electron in the ground state. The ground state is the lowest line on your energy diagram. Notice the weird units that we're using here. ZJ, that is zeptojoules. And so for this, we're just going to look at where that lowest line is on the energy axis. It looks like kind of looking at the marks on here, it looks like each one of these tick marks corresponds to 50. So that would put this at 100 zeptojoules. And then it asks us about the energy in the first excited state. So all of the other states, everything except for the ground state, they are all excited states and they're in order. So this B line is going to be our first excited state, and the C line will be our second excited state. And we're doing the same thing, just reading the energy of this. It looks like it's at 450 zeptojoules. Then it asks us if the electron makes the transition shown by the red arrow from A to C, will a photon be absorbed or emitted? If the line is going up in energy, if the arrow is going up in energy, that corresponds to a photon being absorbed. So this is when we go up in the energy diagram, and if your arrow is pointing down, if you're going down in energy, then that would be emitting a photon. The last question is asking you to calculate the wavelength of the photon that would be either absorbed or emitted. So it doesn't matter what your answer is to this question right here, your calculation is going to be exactly the same. To calculate the wavelength of the photon, we're going to use our equation E equals hc over lambda. Now I do want to say here that it could be asking you to calculate the frequency of the photon instead of the wavelength. If that were the case, you would use the equation E equals h nu. In these equations, h is Planck's constant, 6.626 times 10 to the negative 34 joules times seconds. And if you're using the equation that I need to use, we also have the speed of light in there as well. So it's another constant, 3 times 10 to the 8th meters per second. Then in this equation, our lambda, that's our wavelength, and that needs to be in units of meters. If you're using this equation, that frequency is going to be in units of hertz. And then last but not least, the E that we have in this equation, in both of them, is going to be the difference in energy between the two states that the problem is asking you about. So since this problem is asking me about transition from A to C, the energy that I'm going to use in my calculation is going to be the difference in energy from A to C. So I have to read the energy again. The energy for state C, that looks like it's at 850 zeptojoules. And for A, we've already read that one, that's 100. And again, we're looking at the difference in energy. So they have a difference in energy of 750 zeptojoules. Now the zeptojoule unit is a unit that is absolutely not going to work for this particular equation, whichever one it is that you need to use. The problem tells us that zepto is 10 to the negative 21. So what I'm going to do next is get rid of that zeptojoule unit and convert it into joule units using this relationship that's been given to me in the problem. Zepto means 10 to the negative 21. That means 1 zepto is 10 to the negative 21. And so my joules for this problem are 750 times 10 to the negative 21. And I know that that looks kind of funny when we write things in scientific notation. Normally we want to have a decimal point right here, but it's not going to matter because this isn't our answer. Anyways, we're going to do some additional math with it. So this number here is our E value. That's this number that we're going to use in these equations. And again, that's the difference in the two energy levels that the problem is asking us about. So we know E, we know H, we know C. All we have to do is solve for lambda. I'm going to rewrite this equation E equals HC over lambda. And then what I'm going to do is algebraically rearrange it. So I get E times lambda equals H times C, just doing a little bit of algebra there to get rid of the fraction. And then then I'm going to rearrange it one more time. Lambda equals HC over E. So doing this, what I've done is put all of the variables that I know on the same side of the equal sign, and the variable that I'm trying to figure out, the wavelength, that's all by itself. So all I have to do now is just plug in all of these numbers. H, again, that's Planck's constant, 6.626 times 10 to the negative 34. It's a pretty common constant. You might have, your calculator might have this number programmed into it. Also, ALEKS's calculator, which is with this little tab up here, ALEKS's calculator has these constants programmed into it as well, which is a little bit of a time saver. Next, we have the speed of light, c, that's 3 times 10 to the 8th meters per second, and then we're going to divide that by the energy that we calculated, 750 times 10 to the negative 21 joules. So if we look at our units here, the joules are going to cancel, and then the seconds are going to cancel, and we're going to be left with units of meters. So let's go ahead and do the math on this. We've got 6.626 times 10 to the negative 34 times 3 times 10 to the 8th, and divide that by 750 times 10 to the negative 21, and we get 2.6504 times 10 to the negative 7. The unit that we have left after everything cancels is meters. Now be careful, because look at this, ALEKS wants us to enter it in nanometers. It might not say nanometers every single time. Mine says nanometers, but yours might say something different. So if that's the case, then we're going to have to do one more unit conversion here. So I'm kind of starting to run out of room for doing this unit conversion. I'm just going to see if I can kind of scoot all of this stuff over. Make some room for my unit conversion. To do this, I think I'm going to begin by just picking my 3 sig figs, because the problem says I need 3 sig figs. 2.65 times 10 to the negative 7 meters. I don't want my number to be in units of meters, so I want that on the bottom. I do want nanometers, so I want that on the top. Nano is the prefix that means 10 to the minus 9, so that means 1 nanometer is 10 to the minus 9 meters. My meters are going to cancel, and I am going to end up with an answer of 265 nanometers. ALEKS is going to be really weird about like how you express the sig fig. So even though it feels really awkward, it wants you to put that decimal point at the end of the number. Don't put a 0 at the end, because now it's got 4 sig figs. It's just 265 point with nothing after it, nanometers.